Hello and welcome to day 19. So today we have a bunch of rules that we're going to run through. So our input is a bunch of rules and then a bunch of parts. The way these rules work is we'll start on the end state. So like this is the label for the state. And we'll apply each of these rules. And if the rule matches, then we'll go to this state. So if S is less than 1351, then we go to the PX state. If not, then the last state is always a default. So the default will go to QQZ. But then we go to like PX, and so if A is less than 2006, then we go to QKQ. Otherwise, if M is greater than 2090, then we accept the part. So A is accept, R is reject. And if neither of those, then we go to state RFG. And then each of our objects just has an XMAS value, and we kind of just run through them until we figure out if they're accepted or rejected each. So to do this was pretty simple for the first part. So basically I had to just figure out how I want to organize it first. So since each line in here can have, one, two, or even like 5 rules or something in there, I decided that I'm going to make rule its own separate class, and that's just going to take in the Xmas character of XMAS that it wants to check on, a Boolean for if I'm checking for greater or checking for less than, and then the number it's going to check against, and then the state it goes to if it succeeds. And then in that case, our state is just basically the label and then a list of rules that state contains in order. And then our parts is just going to be the XMAS value and the current state it's sitting in. Then our next parts is just to take all that information in from each line. So I made a parsing function for it because they were just a little bit too big to put in the main function. One thing that I will point out here is the default. So the last rule in here is the one you always go to if nothing else matched, but it doesn't have any checks or anything. It's always always go to RFG. So the way I do this to make it easier to keep basically the same rule set is I just put a basic rule of if X is greater than -1, then we'll go to the last state. And that way, like that one always matches, but I don't have to sit there and worry about edge cases or anything like that. And then for each rule, I just kind of go through and split it up, add it in, and then add the default in at the end, and we're good to go. And then parsing the part, it's a little bit simpler, just break it on the equals and commas and stuff like that, and then there's your XMAS values, and then starts and state in, of course. So then at that point, we can just map our input lines into states and parts. And then our for loop is basically while we have any parts that are not in the state of A for accept or R for reject, then we're going to do this loop. And that's for all parts in that same list of parts that are not currently in A or R. Then we're going to find the state for that part. And then the destination is currently null, and then for each rule I'm going to go through there, and if it's greater than, I'll check the X, if it's greater than and it's an X, then I'll check the X. If it's greater than M, I'll check the M, so on, and check against the number, and then go to that rule state, else null, and then same thing for less than, just with the less than instead. And at the end of that, if we've gone through the whole rule and we're still null, that means nothing matched. And then we just go on to the next rule, the next rule, the next rule. And then of course, when we get to the last rule is if X is greater than -1, so the last rule will always trigger to rule.state, and we don't have to worry about the rest of that. So we basically just run through all of our parts like that until every part has hit its in state, and then we return the sum like they asked. So not too bad. So part 2, of course, they always want you to do it more complicated or longer. In this case, both. The numbers get pretty large. So the only way that really makes sense here is kind of harken back to, I don't know, one of the first weekdays where we had to worry about ranges for seeds and split the seed ranges up. And this is kind of the same thing. So in this case, what we want to do is instead of getting a list of parts, we're just going to ignore the list of parts completely. And we want to find all parts that are between 1 and 4,000 for X, M, A, and S that would match. So, you know, there's 4,000 times 4,000 times 4,000 times 4,000 is some ungodly number of parts to look at, which, you know, your computer will not run through the century. So we have to do it a much more clever way. And that's kind of the same thing we did before, is using the, like we do with seeds, just trying to do it by ranges instead. So for part 2, taking our states, again, we don't even need taking the parts anymore, they don't exist. And then I'm going to have a ghost range that's basically, it starts off with 1 to 4,000, 1 to 4,000 for each, and then it starts in the state in. That's it. That's the only starting criteria. And then our accepted list, because we don't even care about the rejected parts, we just only want the accepted. And while ghost is not empty, then we're going to make a new list of ghosts, which is going to be empty to start with. And then for each ghost piece, then we'll go through and do the same kind of thing we did before, except for split it out. And basically at the end of that, then we'll go through and, you know, set our new list, or next list, to all the parts that we added, replace our ghost list, and we'll keep doing that until that's empty, basically. All right, so for ghosts and ghosts, we'll go through, we'll find the state that is currently in to check the rule set for it. And then for each rule in the rule state, we'll get the range for that rule. So if it's an X check, we'll go get the X range, etc. And if the range doesn't have anything that's in it, like if it's a range of 100 to 0, then there's nothing in there, so we'll skip it. If it does have anything in it, then basically we're going to split the range into 2 pieces. So one is going to be a new piece that we're going to split off, and that's going to be basically if we're looking at greater than, I want the new range to be greater than +1 or the max PR min. So if the current level is like 2,000, I'm checking for 1,000 or higher. I don't want to set to 1,001. I want 2,000 because that's what it's currently at, all the way up to the max. And then inverse for min is we want the current min, and then the minimum of the current max, and the rule -1, because ties go to fail, right? And then this ghost range, I'm going to basically do the opposite, but not with a +1 or -1, because it'll match on the evens. And then that's going to basically become this piece. So we'll add the new part, and then we'll the current part will change the range on this. So what's going to happen on this is, like, we'll have our range of 0 to 4,000 or something all the way through. And then on the end, we'll have a split. So now we'll have 2 things we're going to check against. And one of them is going to be if S is 0 or 1 to 1350, then that one's now in state PX. And the second part is this part we're already checking at. That was 1351 to 4,000 for S, and everything else is still 1 to 4,000. And then that one's now checking this rule, and that rule will send it to QQZ. And then we'll now have 2 in our list, and we'll do both of those. And then the list will spread, and then eventually all of them will hit the end, and they'll shrink. So I hope that makes some sense. So at the end of this, we just need to get the size of each range, multiply them all together, and then spit it out. Which, despite it being a huge number, is actually pretty quick, because we're only ever dealing with most of like 100 things at a time. So I hope that helps. If you got any questions, of course, hit me up in the comments below. Newest code will be on the GitHub as always, and other than that, I'll see you tomorrow.